Hey everyone. So for this project, the topic that I chose was UV oxidation for water remediation. The reason that I chose this topic was because I thought it was really fascinating that we have the ability to treat contaminated water with the process of UV oxidation. I also don't know as much as I should about this process, so I figured it would be a good topic to research on and learn more about. So let's get into it. UV oxidation is basically a destructive process. It targets organic compounds, and the process is via oxidation. Um, so, this is a graphic that shows the process happening, and I will get into that here. The process basically starts with an oxidizing agent. The oxidizing agent is then added to the groundwater that has the contaminants. Usually, the agent is ozone or hydrogen peroxide. Then the water is put through a chamber where it is exposed to extreme UV radiation. The contaminants are oxidized due to a reaction with the oxidizers, and the UV radiation itself comes from specific UV light bulbs. So here in the graphic, you can see pretty much what I said visually displayed. On the top left, it shows the target contaminant, which is going to be the groundwater with the contaminants in it entering the chamber. Then it shows the area with the specific UV light bulbs on the UV lamp. This is where the UV radiation process will occur. And then on the right, the treated water will come out of the chamber. So, like any process, this process comes with its own pros and cons. So, some of the pros about this process is that almost any contaminant, as long as it is organic, can be treated through UV oxidation. An example of such contaminants would be petroleum hydrocarbons and chlorinated hydrocarbons. And chlorinated hydrocarbons are actually used in industrial solvents and cleaners. So they're pretty nasty, and it's really good that this process can has the ability to target chlorinated hydrocarbons because we definitely don't want that in our water. Also, the UV is transmitted really well to dissolved contaminants. Some of the cons, however, is that the system does not destroy some organics, which are volatile. So, an example of this is TCA. And what happens instead is that the contaminant may be vaporized, and then after it's vaporized, it would need to be treated in an off gas system. So that's definitely not ideal. Um, Another con is that there are very high energy requirements in the system, and also the initial hydrogen peroxide that I talked about that we have to add into the system. That's not easy to handle. So it requires a lot of specific safety measurements. It's not easy to handle, not easy to store. So that can definitely be a con for this whole system. So the cost for UV oxidation has a pretty wide range, as you can see. I mean, it starts from 0.03 all the way up to $3 per 1,000 liters. And the reason is because there are certain factors which affect the price. Um, One of the factors can be contaminant concentration. So the concentration of the contaminant has an effect on what oxidizer you're selecting, the dosage of the oxidizer, how intense you want the light to be, and even the treatment time. So all of these would have an effect on the price. The water flow rates can have an effect, and even the degree of destruction. So I mean, from the name, it's how much you want the contaminants to be destroyed. So all of these factors can directly have an effect on how expensive the whole process can be. But in general, I think this is a pretty interesting and cool process because, like I said, it has the ability to destroy almost all organic contaminants as long as they're not volatile, like I said, like TCA. But that's pretty awesome, especially for nasty stuff like chlorinated hydrocarbons. So it's, you know, it's a pretty cool system that has the ability to do all of this just by using UV. But anyways, that is basically all I have. I hope you enjoyed my presentation and have a nice day. Bye.